Hello and welcome, I'm your Code Monkey, and here let's learn how to use Unity Relay. This is their tool for helping you handle multiplayer connections without needing dedicated servers and without asking your players to open ports and share IPs. So there are no more issues with firewalls, NAT, and so on. You just connect to the Unity Relay, get a join code, share that code with your friends, and then they can easily connect to the same server. The other Unity tool which works very well with Relay is Lobby, which I already covered in detail in the previous video. When you combine both, you don't even need to share the Relay code, you can do it automatically through Lobby. And I've also covered Unity's Netcode library called Netcode for Game Objects in another video. All three of these tools are completely independent, you can use just one or any combination of these, but they are also made to very easily work with one another. Here in this video, let's focus on the Relay, but that part is actually extremely simple, it literally just takes 3 lines of code, so I will also showcase how to use it in conjunction with Netcode for Game Objects and Lobby. With that, we can create a lobby, the second player can join, the host starts the game, and both players connect through the Relay and play the game with Netcode for Game Objects. Also, this video is officially sponsored by Unity Gaming Services. This is a collection of tools for helping you build, operate, and grow your games with ease. It includes all of the tools that I'm going to mention here. Netcode for Game Objects for adding multiplayer to your games. Lobby for joining players. Relay for connecting them. There's also a dedicated game server tool, one for matchmaking, Vivox for voice and text. You have Cloud Save for storing player data in the cloud, Cloud Content Delivery for delivering assets to your players. You can explore your game analytics, do some A/B testing, monetize with ads, or do in-app purchases, or a bunch more. All of these tools are either completely free or they have generous free tiers, so click the link in the description to learn more about Unity Gaming Services and get started for free. Okay, so here I will be starting from where I left off on the Netcode for Game Objects video. So I've got 2 builds right here, and these 2 buttons where I can start as a host or a client. So this one, let's make it a host. On this one, let's make it a client. And there you go, both of them are connected in multiplayer. Alright, great. However, the issue here is that the only reason why this is working is because I'm running on the exact same PC. If I tried to send this build over to a friend and have them connect, it would not work. It would have issues with firewall, so I would have to manually open up ports and disable the firewall. Relay is a tool that helps you solve that, so you don't need to do that. Okay, so here is a working demo using Netcode for Game Objects, but like I said, Relay works by itself without Netcode for Game Objects, so let's first look at the absolute basics. The first step is to install the package, so let's open up the package manager. Let's go up here into the Unity registry, and then find over here the Relay package. So just go ahead and install this. The next step is to set up a project on the Unity dashboard. So you can go here into Edit Project Settings, then go down into Services, then make sure you're logged in. And over here, you can select the organization and create a project from here. Or if you already made the project in the Unity dashboard, then you can click here and just assign the project. I already created the project, so over here, I'm just going to select my project and just link the project. Okay, the project is linked. Now let's go here into the Unity dashboard. Make sure you select the project up here. Then on the left side, let's select multiplayer. And then over here, let's go under Relay. And over here, you should be able to see a button to enable it. Then you can go through the setup guide. So first of all, it tells you to link the project, which we already did, so let's go on next. Then it tells us to install the package, which we did, next. And finally, turn on the Relay, next. And that's it. If you want, there are also some really nice samples that you can download to see how it all works. Okay, so that's the basic setup done. Back in our project, let's create a brand new C# script. Let's call this test relay. Let's make a game object to run it. Attach the script and let's open. Okay, so now here the first thing that we need is we need to initialize the Unity services. So let's make a private void start, and on start let's do that. By the way, this initialization part for the Unity services and authentication, this one is the exact same as the lobby. So if you've already seen that video, you can fast forward this part. There's timestamps in the video. So we go inside Unity services, which is inside unity.services.core. So let's add that using in here, and we just call initialize async. Now importantly, this is an awaitable call, so up here let's add await. And in order for this await to run, then we need to define this function as async. Now if you're not familiar with async and await, don't worry too much about it. You don't need to know how it works in order to use it. But essentially what it does is it lets you run code asynchronously. So for example, over here, this will send a request to the Unity services to initialize the API. That request goes over the internet, so it's not instant. If you didn't make it async, then the game would freeze until it receives a reply. That's the main purpose of async and await. With this, your game does not freeze. It pauses the execution of this function and the rest of the game keeps going. So any code that we write down here, it will not run immediately. Instead, the execution will pause in here until it receives a reply. Then when it does, then this function continues executing. But like I said, you don't need to worry about it, just don't forget the await and async keywords. Okay, so this is all we need to initialize these services. Then Relay requires authentication to use. Unity Authentication has tons of options. You can link a SIM account, Apple, Android, Facebook, or OpenID. So you can use that to create an account and link with any of those services, or something super awesome, which is you can just do a super quick anonymous sign-in. Over here, all we do is access the authentication service, this one right here inside Unity Services Authentication. And then we can access the static instance, and then we call sign in anonymously async. Again, this one is an awaitable call, so let's await. Basically, this will sign in anonymously and create a new account for this user. If we want, we can listen to the event to know when the sign-in completes. So again, let's go into the authentication service and listen to the signed in event. So over here, for example, let's do a debug.log. And we can go into the authentication service instance in order to get the player ID. We can do a quick test just to verify this is working. And if there it is, it signed in and gave me this player ID. Okay, so we have everything we need to start using the relay. So let's begin by making a function. So a private void, let's call it create relay. And over here, the first thing we're going to do is create an allocation. So for that, we're going to access the relay service inside unity.services.relay. On this one, we access the static instance, and we're going to create an allocation async. And this one takes a parameter for the max number of connections. Importantly, this does not include the host creating the allocation. So for example, if you have a 4-player game, that means it's going to be the host plus 3 more players. So over here, you just put 3. Then optionally, you can also define which region you want to create the allocation in, or you can just leave it as empty and just let the relay decide which is the best region. And again, this one is an awaitable call, so let's await and async. Now, one important thing about this function, and really every relay function, is that it can throw an exception. If we do just like this and throws an exception, then it's going to pretty much break our whole game. We don't want that to happen, so let's make sure to wrap these functions inside a try catch. So try, then catch, and we can catch a relay service exception, so relay service exception. And if that happens, let's just do a debug log. With this, if we have any errors, we will get some details on what went wrong, like for example, maybe the relay is disconnected or disabled or so on. Okay, so with this over here, we are going to return an allocation. Let's grab that object of type allocation inside Unity Services Relay.models. So our allocation. And then with this allocation, the next thing we need is to generate a join code. So again, let's go into the relay service and access the instance. And now let's get the join code async. And we need to pass in the allocation ID. So let's go into allocation and pass in the allocation ID. Then this is going to return a string. So it's a string for our join code. And again, this is awaitable. So let's await. Okay, so that's it. It really is this simple. With this, we are creating an allocation on the relay and then getting the join code to join that allocation. The string that we get here is going to be the code which we can send to our friends so they can connect to the same relay. Let's do a quick test just to see what this is doing. And for testing, like I was using in the Netcode for Game Objects video, over here I'm using the Quantum Console. It's an excellent asset that lets you easily add a console. I made a full review on it, really awesome. Here it is especially useful, so we can call this function. So to do that, I'm just going to add the attribute command. With this, I can easily call this function from the console. Now this is optional, you don't have to use this asset. You can call this function from wherever you want. I'm just doing it like this just to make it easier for the demo. Okay, so with this, let's test. All right, here we are signed in. So now let's call our function to create the relay. So let's run that. And yep, there you go, it did work. So over here, you can see that it pinged a whole bunch of servers in order to find the closest one. And in my case, it decided that the best region was Europe West 2, which makes sense since I'm in Portugal. So yep, everything worked correctly. I just forgot to add a log for the join code, so let's do that. So over here, after we get the join code, just do a debug.log on the join code. Again, let's create a relay. And yep, there you go, there we have our join code. Okay, great, so we created the allocation and we got the join code. Now the next step is to join using this code. So over here, let's make another function, private void, let's call it join relay. And we're going to receive a string for the join code. Then over here, it's pretty simple. Let's just access the relay service, get the instance, and now let's call join allocation async. This takes our join code, so let's pass that in. And again, this is awaitable. Let's put async, and let's make sure to put this inside a try catch again, so that this whole thing doesn't break. Alright, so here it is. It really is this simple. This is all you need to get the relay working. So on the host, you create an allocation and generate a join code, and then on the client, you simply join using the join code. Now, this is the part where normally I would do a quick test to showcase that it is indeed working, but while this code does work, if we test just like this, so over here I've got 2 builds running. Now on this one, let's call create relay. So let's create it. Yep, there you go, got the region, got the code, okay, great. And now on this one, let's call join relay, and then just pass in the code. So in this case, FCCCG7. So let's join. And nope, there's the error. It's saying the join code is not found. Basically, everything is indeed working correctly, except the relay won't really open if you don't immediately make a connection. After you allocate the relay, you need to open a connection in whatever way you want, using whatever transport you want. So this is where we can connect relay to Netcode for game objects and Unity transport in order to open that connection and make everything work through the relay. So let's do that. The first setup is let's go into the network manager object. So here it is. Again, I set up all of this in the Netcode for game objects video. Go watch that if you have no idea what is a network manager. So down here, if we scroll, we can see we're using Unity transport, and for the protocol type, over here it says Unity transport. All we need to do is on this drop-down menu, let's swap for the relay Unity transport. And that's it, there's nothing else we need to change here. And now for setting up the transport to use relay, this is going to differ slightly depending on what version you're using. So if you find any issues, pay close attention here. There are 2 methods. The second method is newer and quite a bit easier to use. But first, let's begin with the first method. This first method is if you are using Netcode for game objects version 1.0.2, which as of the time of this recording is the version that you can get from the package manager. And also down here, the Unity transport version 1.2.0. So these are the versions that I use in the Netcode video. With these specific versions, let's see how it is. First, over here, when we create the relay allocation, we get the join code, then we can access the network manager, which is inside unity.netcode. Then on this one, we can access the singleton, and through the singleton, we can do get component in order to get the component of type Unity transport. Then on this one, we can call set host relay data, so this function, which as you can see takes tons of parameters. All of these parameters we can get from the allocation, so let's add all of these. The first one is the IP address, so let's go into allocation, let's grab the relay server and grab the IPv4. Next one is the port, so allocation, the relay server, and let's grab the port. Although this field accepts a ushort, whereas port over here, this one is an int, so we need to convert it, so back into ushort. Okay, we have the port. Next one, the allocation ID, so again, allocation, let's get the allocation ID bytes. Then for the key, that's an allocation.key. And finally, the allocation.connection data. Okay, so with this, all of the parameters have been set. And then over here, we can start the host, which will finally create the connection. So let's go into Network Manager, get the singleton, and let's call start host. Okay, that's it. That's all it takes to set up the Network Manager to work with relay. And then down here, when joining, we join the allocation via the code, okay. Then let's again go into the Network Manager, access the singleton, let's do a get component to grab the Unity transport. And then on this one, instead of calling set host relay data, we call set client relay data. So pay attention, it's a different function. And now we need the same bunch of parameters, so let's add them. And for the parameters, we can get them from here. So when we join the allocation, this returns an object of type join allocation. So let's grab the join allocation. And from this one, we can grab all of these parameters. So first of all, once again, let's go relay server, grab the IPv4 and so on. So here we have the connection data, and on this one, we've got an extra one. So that's the join allocation, the host connection data. All right, so we set up the Unity transport with the set relay client data. And then afterwards, we can start our client. So again, network manager, let's access the singleton. And let's call start client. All right, so that's it. So with these two, our Unity transport connection should now be handled through the relay. So let's test. Okay, so here I have both builds. Now on this one, let's call create relay, which is going to create the relay and start the host. So there you go, it does. And yep, my character is here. So yep, it does work. And there we have our code. So then down here, let's call join relay, pass in the code. So the 7FFF6M. So let's join. And yep, there you go, it did join, and we have both players connected in the same world and both connected through the relay. All right, awesome. So as you can see, I can move and everything is nicely synchronized on each of them. Okay, great, everything works. Now let's see the newer, simpler method. First of all, let's install new versions. Now, like I said, at the time of this recording, the new versions are released, but they don't show up on the package manager automatically. So we can't install it over here through the list, but we can go and add package by name. And for this one is the com.unity.netcode.gameObjects. And the version that we want to install is version 1.1.0, so let's add this one. Okay, here it is, so Netcode for Game Objects, I've got installed version 1.1.0, and importantly, it also automatically installed Unity Transport 130, so down here, make sure we have this one, the 1.3.0. So this is important. For this new method, you need these two versions for both the Netcode and the Transport. So back here in the code, instead of having to send all of these parameters one by one, there's a simpler method. There is a different function, so instead of being setHostRelayData, we call setRelayServerData. So we call this one, and we have version which takes a relay server data, so we can create that object. So here, let's make of type relay server data inside Unity Networking Transport Relay. And on this one, we can use the constructor, and the constructor takes an allocation, so let's pass in the allocation, and then also has a connection type. This can be either UDP or DTLS. DTLS is encrypted, and it's what they use in docs, so let's use that here. So DTLS. And yep, that's it. So we now have this relay server data, and over here, we just use this instead of sending all these parameters. Okay, that's it. As you can see, much simpler method. Then on the client down here, let's use the exact same thing. So let's actually copy this and paste on top of this. So we have this we created based on this join allocation and do exactly like this. So now we use the same function and just pass in a relay server data. All right, now let's test like this. So here are both builds. On this one, let's create the relay. And let's go, it's going to create, and yep, start the host, so there you go, it works. And on this one, let's call join relay, pass in the code, and yep, it joined the relay, started the client, and yep, everything does work. Okay, great. Now let's verify that it does indeed work. So here on my PC, I'm using my regular connection. You can see that I'm in Portugal. Then on my laptop, I'm using a VPN, so you can see that I'm connecting through the Netherlands. In this scenario, if we did not use relay, then I would have to manually open my firewall and open some ports. But with relay working, let's just connect. So over here on my PC, I'm going to create a relay. There it is, placed in Europe West 2. Okay, great. Now on my laptop here, let's join the relay. And yep, there you go, we have a nice connection. So again, I'm connecting through a VPN, so both builds are running on different IPs. And as you can see, everything is working perfectly, so everything is synchronized, so I can do exactly anything that I want. There are no worries with that, no problems with firewalls. Everything is connected nice and seamlessly. All right, awesome. Now, finally, let's look at how to get it working with Lobby. I covered Lobby in detail in the previous video, and here I have the demo sample that I built in that video. So I've got 4 windows open. I can set the name, so I've set unique names just so they authenticate with different player IDs. So let's join with all of them. Now, for example, on this one, I can create a brand new lobby. So let's make it public, my lobby with 4 players, and capture the flag. Let's create. And there you go, there's the lobby. So now on the other ones, if I search, I should be able to see that lobby. And yep, I do see it on all of them. So now I can just join with all of these. So join with that one, and there you go. All 4 are currently joined in the same lobby. Then like I showed in the lobby demo over here, I've got tons of options. So I can change the character, I can change anything I want, I can change the game mode, I can kick players, I can leave, and so on. So this is a fully working lobby. So far, everything here is exactly the same as the sampling in the lobby video. The only thing I changed was adding this nice arrow button here. What this does is it starts the game. So when I click on that button, it triggers this. So we go to start game on the lobby manager. Then on this lobby manager, here is the code. Basically, lobby can source some data. So the way that I decided to synchronize the relay joining code is by setting it as some lobby data. So up here, when we create a lobby, so here is the function to create a lobby. And on the data, I included one for the start game. And I just defaulted it to 0. Also importantly, remember how lobby has some data accessors. For the relay, you don't want that to be public. That would be accessible to anyone searching for a lobby. You only want it to be visible to people inside the lobby, so that's why I made this one a member variable. Then I just defaulted it to 0, and then on the start game function, on this one, just make an update to the lobby and set this one into the relay code. So I basically just go into the test relay function that we just made to create the relay, and this function is going to return the join code. So it allocates the relay, sets Unity transport, starts the host, and returns the join code. So it does that and updates the lobby with the relay code. Then for all the other players, if we saw the lobby video, they are constantly polling for lobby updates. Over here is the function to handle the lobby polling, so it's constantly getting for updates. And then over here, it checks for the lobby, check the data, check the start game. And if it is not 0, which was the default, if it is not 0, then it contains the relay code. If so, then just does a check if this one is the lobby host, because the lobby host joins automatically when it generates the code. And if not, just call the join relay and join the relay, pass in the relay code. And that's really it. When joining the relay, this one starts up the client, and the host starts when it generates the code. So everything should work, they should be connected. Although before I test this, let me point out that alternatively, you could decide to start the real-time connection right away. Over here, I decided to pretty much only create the relay allocation and only start Netcode for game objects, and only do that as soon as the player decides to start the game. But you could call start host directly as soon as anyone joins the lobby. That would be useful if, for example, you wanted to have some relay data transfer whilst inside the lobby. Perhaps you wanted some more complex options to share while the players were inside the lobby. Over here on the sample, as you saw in the previous video, if I click somewhere to update it, you can see it takes a little bit of time before it updates in all the other clients. Again, that is because the lobby is not meant for real-time connection. That is why it only polls once per second. So alternatively, if you wanted, you could start the host and start the clients as soon as they enter. Or you can do what I did here, which is it only creates a relay allocation when we press the start game button. It's up to you to decide which method makes more sense for your game. Alright, so with everything set up over here on the host, all that's left is to start the game. So I'm going to press this button, and this one is going to generate a relay allocation and then start Netcode for game objects. And at the same time, these other clients, they are going to poll for updates, and within about 1 second, they are going to get the update, they are going to connect to the relay, and they are going to start Netcode for game objects. So let's see all of that in action. Over here, let's click, and there you go, it's allocating the relay, and in a bit, yep, there you go, starts the host, and the host right here, and all the other ones are connecting. There you go, this one, and this one, and this one. And all of them are connected, all of them connected through a lobby, and all of them are being connected through the relay and handling the real-time data through Netcode for game objects. Alright, awesome! So again, note how we did all of this without having to share any text, any relay join code, anything like that. We just used the lobby, we found an open public lobby, and we just joined it, so no need to handle any codes, anything at all. It all works seamlessly under the hood. And here we have a nice game with 4 clients all working together, all playing in the same game. Alright, great. Now let me point out just one more quick note. Like this, the lobby still exists. Those players are still connected to that lobby. Again, that is up to you to decide how you want to handle it. Perhaps you do want to keep them in the lobby, so that if something happens, like for example, one of these hosts disconnects, if that happens, you can go back to the lobby and start another game. Or alternatively, you can decide to destroy the lobby as soon as the game starts and not allow anyone else to join. So it's up to you to decide what makes sense in your game. Do you keep the lobby alive, or do you destroy it as soon as the game starts? Okay, so finally, let's look at pricing. Over here on the UGS pricing page, we can scroll down and find the relay. So over here under multiplayer, here it is, multiplayer, and we've got the relay and lobby. The left side is the free tier, and the right side is the paid tier. So for the relay, we have a free tier with 50 free CCUs per month. CCU means concurrent users. So you can have 50 players connected at the exact same time, all of that for free. Again, remember those are not 50 players total, it's 50 players at the exact same time. So you could have thousands of players, as long as they're not all playing at once and you stay within the free tier. Then for bandwidth, for this one you have 3 GB per concurrent user and 150 per total per month. This is obviously going to depend on a per game basis, but these free tiers seem pretty generous to me. 150 GB per month is quite a huge amount. Quite a lot of bandwidth. And if you end up going past these free limits, then the paid tier is also pretty cheap. If your game was a massive hit and you had 1,000 concurrent users, then it would only cost you about $160. And if you had 1,000 concurrent users, that would probably mean that you sold something like 50,000 copies, so these values look pretty cheap. But again, for the most part, you're probably going to stay within the free tier, so that's great. Alright, so that's Unity Relay. It's an awesome tool for helping you make multiplayer games without requiring dedicated servers and without requiring your players to deal with firewalls or port forwarding or anything with IPs. Then when combined with Netcode for game objects and lobby, it makes it really easy to make multiplayer games. If you've tried to make a multiplayer game just 5 years ago, it would have been extremely difficult, but now thanks to all of these tools, it's all extremely easy. So now go ahead, take these tools and build some awesome multiplayer games. Alright, hope that's useful. Check out these videos to learn some more. Thanks to these awesome Patreon supporters for making these videos possible. Thank you for watching, and I'll see you next time.